Hello, Leon. It's your Zayde, Mason. I'm here today to talk to you about statistical physics for babies. This is for you. Let us begin. This is a ball. We almost always start with a ball, and this ball is red. This ball is on the left. See, that's the right, and that's the left, and this ball is on the left. Now the ball is on the move. See, it's got a little arrow. It's moving from the left, and it has now moved to the right. Now it's on the right. Moved from the left to the right. Here there are 6 balls. 1, 2, 3, 4, 5, 6. There are 6 balls, all inside that box. These balls are on the move. They're all moving. These balls are not moving. They're just sitting there. These ones are not stationary. They are in motion. They have little arrows to represent their direction of motion. Sometimes there are more balls on the left. They're all in motion, but these ones are all on the left. Sometimes there are more balls on the right, and this time there are more on the right and one on the left, and they all are going in each in their own direction. Very rarely are they all on the same side. See, they're all on the left and none are on the right. But we usually find them like this, with an even number on both sides of both of them. So there's 3 on each side, and they're still all in motion, but there's 3 on this side, 1, 2, 3, and 3 on this side, 1, 2, 3. There's still 6 balls. Half are in this side on the left, and half are on this side on the right. So let's continue. Ooh, now each ball is a different color. Red and purple and yellow and blue and green and orange. There's 6 balls, and they're all different colors. Remember, we had 6 balls before? Now they're different colors instead of all red. There's only one way for all these balls to be on the left. That is, all of them on the left and none of them on the right. There are 0 other ways for them all to be on the other side. But there are 6 ways for the balls to be on the left with 1 ball on the right. See how there's 1 ball in each case that's on the right, and it's of just one color, red and yellow and blue and purple and green and orange. And see, when it's on one side, it's not on the other. So here everything but red is on the left and red is on the right. And here it's true for yellow, and here it's true for blue. So there's only 6 ways for that to be. Now, there are 15 ways for 2 balls to be on the right, and it shows all the different ways that it can be. I'm not going to go through all of them, but they're all there, and there's 15 different ways for that to happen. Now, there are 20 ways for half of the balls of each different color to be on either side. 20. So there was only 6 possible ways for 1 ball to be on the right, and there were 15 for 2 to be on the right. There are 20 for 3 to be on each side. And that is why we see this configuration more often, because it's more probable. Physicists call the number of different combinations entropy. Well, it's one name for it. We can also call it a Gaussian distribution, sort of like rolling dice. And when we teach you about dice later on, we'll show you how dice roll with different combinations. But this is very much like that. And in this case, for statistical physics, we call it entropy. This is low entropy when they're all on one side, all on the left or all on the right. In this case, they're all on the left and all in motion. That's low entropy. High entropy is when they're distributed on either side approximately evenly. Even if all the balls are on one side, they end up this way because it's much more likely. Remember, there are more possible ways for the balls to be in this configuration than this. There's only 6 of this possibility. There's 20 of this possibility. So they start this way, and they usually end up this way. Things tend to move from low entropy to high entropy. This is the second law of thermodynamics. So yes, when things move from low entropy to high entropy, that's the second law of thermodynamics. In order to move from high entropy to low entropy, you must put in effort and energy. See, you actually have to make these balls move towards that side, and it takes effort and energy. Things naturally go from organized to messy. See, this is organized, and this is how it tends to end up. Sort of like when we talk about mixing ingredients together. You can't really unmix them once you've mixed them, or the state of your bedroom after a period of time. Especially when you get older, it will get messy and it won't just clean itself. But you'll learn about that later, and we'll talk about it. Anyway, now you know statistical physics. Yay! Anyway, we have learned about statistical physics today, and I love you very much, Leon, and I hope you have a good day, and I will teach you more physics soon, okay? I love you. Bye, Leon.